There may be more planets out there with no sun at all, worlds drifting alone in total darkness, than there are stars in the entire Milky Way. Just sit with that for a second. Right now, while you're lying there are more lonely, sunless worlds wandering the galaxy than there are points of light in the whole night sky. And honestly, that's not scary. That's kind of beautiful. Stick around, because tonight we're going on a slow, quiet drift through the softest, weirdest, most calming truths about the cosmos. The kind of facts that make you feel small in the best possible way. If this is your thing, slow space, strange truths, and a voice telling you about the universe while you melt into the couch, go ahead and subscribe. We post these every single week. And yeah, you can hit the little bell too if you want. No pressure, just settle in. Okay, so let's start with those rogue planets, because they really are one of the gentlest, strangest ideas in all of astronomy. When you picture a planet, you picture it the way you've always been taught. There's a star in the middle, bright and warm, and the planet loops around it in a neat little circle, year after year after year. Earth does it. Mars does it. Every world you learned about as a kid does it. That's just what planets are, right? They orbit a sun. That's the whole deal. Well, here's the thing. The universe didn't read that rule book. Out there, scattered across the dark between the stars, there are planets that belong to no sun at all. Astronomers call them rogue planets, or free-floating planets, and they don't orbit anything. They just drift, slowly, silently, through the vast empty spaces between the stars, in a night that never ends and never has a sunrise coming. No dawn, no seasons, no warm little star to circle, just endless, patient drifting through the dark. And you'd think these would be rare, right? Some weird cosmic accident, a 1 in a billion oddity. But here's the part that gets me. Scientists now think there might be more of these rogue planets in the Milky Way than there are stars. Let me say that again slowly, because it deserves it. There may be more sunless, wandering worlds in our galaxy than there are suns. Some estimates put the number in the trillions. Trillions of dark planets just floating out there. Each one a whole world with mountains and valleys and frozen plains, and not a single one of them has a sky with a sun in it. Now, how does a planet even end up like that? How do you lose your sun? It turns out being homeless in the galaxy is surprisingly easy. When a solar system is young, it's a messy, chaotic place. You've got a bunch of baby planets forming around a new star, and they're all jostling for position, tugging on each other with their gravity, swinging close and pulling away. And every now and then, one of these young worlds gets the gravitational equivalent of a slingshot. A bigger planet, like a Jupiter, swings by at just the right angle and flings the smaller one clean out of the system, out past the last orbit, past the edge of the family, out into the open dark where nothing will ever pull it back. And off it goes. No goodbye, no catastrophe even, just a quiet drift into the night, carrying its mountains and its oceans turned to ice, alone now, forever. There's something almost tender about it when you think of it that way. Not a tragedy, just a world that got loose and went wandering. And here's where it gets even softer and stranger. You might assume that a planet with no sun must be a frozen, dead rock. And on the surface, sure, it's brutally cold. We're talking temperatures barely above absolute zero on the outside. But some scientists think rogue planets could still keep liquid water hidden deep underground, because a planet generates its own heat from the inside, left over from when it formed and from radioactive decay deep in its core. That internal warmth doesn't need a sun. So beneath miles of ice in total darkness, there could be warm oceans on these wandering worlds, hidden seas drifting through interstellar space, with maybe, just maybe, the conditions for something to live in them. Whole secret oceans sailing silently through the galaxy, and you'd never see them from the outside. They'd look like nothing, just dark, cold rocks in the dark, cold night, hiding warm water and who knows what else. Isn't that a strangely comforting thought that even out there, in the most isolated, sunless places imaginable, the universe might still be quietly keeping things warm? Life, or the possibility of it, tucked into the dark and carried along, no sun required. Now, here's something to settle into. While you're lying there, picture the closest one of these. The nearest rogue planet might be only a few light years away, closer, in some cases, than the nearest star. Somewhere out in that direction, beyond everything you can see, a whole world is drifting through the dark right now, in silence, in a night that has lasted billions of years and will last billions more. And it's just fine. It's not in distress. It's not falling. It's just going where the galaxy takes it, slow and quiet and patient. There's a peace in that. The universe is full of things that are perfectly content to simply drift. And now, let me take you back, way back, further back than any planet, rogue or otherwise, because I want to show you the oldest thing you can possibly see, and it's a kind of light that's still arriving right now, this very second, even as you breathe. Let me explain. You know that the universe began with the Big Bang, around 13.8 billion years ago, but the very early universe wasn't something you could have looked at, even if you'd been there. For the first few 100,000 years, the whole cosmos was a hot, thick, glowing fog. So dense and so blazing hot that light couldn't even travel through it. Light would try to move, and it would immediately smash into a free-floating particle and bounce again and again, trapped, going nowhere. The entire universe was opaque, a glowing, foggy soup, lit up from the inside, but impossible to see through. If you'd been there, you'd have been swimming in light and yet completely blind, surrounded by a glow with no distance, no shapes, nothing. And then, something gentle happened. As the universe expanded, it cooled, and about 380,000 years after the Big Bang, it cooled just enough. The temperature dropped to a point where finally, those swirling particles could come together and calm down. Electrons settled into orbit around nuclei, forming the first calm, neutral atoms. And in that moment, all across the cosmos at once, the fog lifted. Suddenly, for the very first time, light was free. It could travel. The universe became transparent, and that light, that very first light that was finally set loose when the universe became clear, is still traveling. It has been traveling for 13.8 billion years across the whole expanding universe, and some of it is reaching us right now. We call it the cosmic microwave background, and it is the oldest light there is. It is, quite literally, the afterglow of the Big Bang, the memory of the exact moment the universe became transparent, stretched and softened over billions of years. Now, here's the part that I find genuinely soothing. When that light first set out, it was a fierce, hot glow. But the universe has been expanding the whole time it's been traveling, and that expansion has stretched the light. It stretched those waves out, longer and longer and longer, cooling them down, calming them, until that ancient blazing flash has become a faint, gentle whisper of microwave radiation. The fire of creation, softened over 13 billion years into something almost cold, something quiet. The universe took its loudest, hottest moment and gently turned the volume all the way down. And this light is everywhere. It's not coming from one spot in the sky. It's coming from every direction at once. A faint, even glow filling the entire sky, all around you, all the time. You are sitting inside the afterglow of the beginning of everything, right now. It's passing through your room. It's passing through you. A faint, ancient warmth left over from the moment the universe first cleared its eyes and could see. And here's a small, strange piece of it you might have actually met without knowing. Back in the days of old analog televisions, the ones with the antenna, when you tuned to a channel with no signal, you'd get that black and white static fuzz, that hissing snow. A tiny fraction of that static, a small percentage of it, was the cosmic microwave background, the afterglow of the Big Bang, picked up by your TV antenna and turned into the gentle crackle of an empty channel. The oldest light in the universe, faintly humming through your living room set. You were watching the birth of the cosmos and just thinking your TV was broken. So think about that as you lie there. The oldest light we can see left its source 380,000 years after the Big Bang, and it is still arriving, even now, stretched and cooled into faint microwaves, carrying with it the memory of the entire universe becoming transparent. It traveled for 13 billion years to get to you tonight, and it made it. After all that time, all that distance, all that stretching and cooling, it finally arrived, soft and quiet, in your sky. There's something profoundly peaceful about being the place where ancient light finally comes to rest. Now, speaking of dead stars and ancient things, let me take you somewhere that sounds like a fairy tale, but is absolutely real. Because somewhere out there in the galaxy, there are planets made almost entirely of diamond. Okay, so here's how that even happens, and it's a wonderfully strange story. When certain stars die, they don't all explode dramatically. Some of them, stars like our own sun, end their lives much more gently. The star swells up, sheds its outer layers in a soft, glowing cloud, and what's left behind is a small, dense, slowly cooling core called a white dwarf. It's the corpse of a star, basically. A burnt-out ember, roughly the size of the Earth, but incredibly heavy, sitting there in space, fading over billions and billions of years. And here's the thing about these stellar corpses. They're made largely of carbon. And we know what happens to carbon under enormous pressure, right? You squeeze carbon hard enough, for long enough, and it crystallizes. It becomes diamond. So picture a star's leftover heart, packed full of carbon, slowly cooling and crushing under its own gravity over billions of years. Scientists believe that some of these white dwarfs may eventually crystallize, the carbon inside them lining up, atom by atom, into a vast crystal structure. In other words, a dying star can slowly turn into a diamond the size of a planet, an entire cosmic gemstone drifting in the dark. The crystallized corpse of a star that once shone. There's even a famous one. Astronomers found a white dwarf that they think has largely crystallized, and they nicknamed it Lucy, after the Beatles song, Lucy in the Sky with Diamonds. A diamond as big as a planet, hanging quietly in space, all that's left of a star that lived and died and slowly turned to crystal in the dark. But it gets even better than that, because there are also actual planets, worlds orbiting other stars that astronomers believe could be made largely of crystallized carbon, diamond worlds. Imagine that. A planet where, instead of soil and rock, you've got layers of graphite and diamond, glittering and dark, formed because that world was born in a place rich with carbon. There's a planet astronomers have studied, orbiting another star, that they think might have a surface and interior built from diamond and graphite, possibly a third of its entire mass being pure diamond. A world worth more than every economy on Earth combined, just sitting out there in space, orbiting its star, completely indifferent to how precious we'd think it is. And that's the part that I love, honestly. Out here, a diamond as big as a world is nothing special. It's just what happens when carbon and gravity and time get together for a few billion years. The universe makes treasure the way it makes everything else, slowly, patiently, without ever caring whether anyone's around to be impressed. Whole worlds of glittering crystal, orbiting the cooling corpses of dead stars in total silence for no one. And somehow that's not lonely, it's just calm. The cosmos quietly crafting jewels in the dark and never once asking for them back. Now let me bring this a little closer to home, a little closer to our own sun. Because here's a thought that's both eerie and strangely sweet. Our sun might have been born with a twin. Let me explain this one, because it's lovely. When stars form, they almost never form alone. They form in big clouds of gas and dust called stellar nurseries. And out of these clouds, stars tend to be born in pairs or groups. In fact, a huge fraction of the stars you see in the sky aren't single stars at all. They're binary stars, two suns orbiting each other, dancing together through space. It's actually more common for a star to have a companion than to be alone. So when our sun formed 4.5 billion years ago, the odds are good that it didn't form by itself. It probably had a sibling, a twin star, born from the very same cloud at the very same time. Scientists have even given this hypothetical lost twin a name. They call it Nemesis. And the idea is that long ago, our sun and its twin were born together, side by side in the same stellar nursery. But stellar nurseries are crowded, busy places, full of other stars and gravitational tugs. And over time, the gentle pull of all those passing stars slowly pried the two siblings apart. Our sun's twin drifted away, off into the galaxy, and the two of them lost each other in the crowd. Billions of years ago, they went their separate ways. And here's the part that gets me. That twin could still be out there, right now, somewhere in the Milky Way, orbiting the center of the galaxy just like our sun does. There might be a star that was born in the very same cloud as our own, a sibling sun that drifted off and was never seen again. We don't know which star it is. It could be one of thousands you can see, blended into the rest of the sky, completely unrecognizable now. A long-lost sibling, hiding in plain sight among all the other stars, and neither of them knowing the other is there. Think about that for a second. Lying there, the sun that warms your face, the star our entire world depends on, may have a brother or sister out there in the dark, drifting through the same galaxy, having gone its own separate way billions of years before there were oceans on Earth, before there was anyone to look up and wonder. Two stars, born together, separated by time and distance, still circling the same galactic center, still part of the same vast, slow turning, even though they'll probably never meet again. There's something so human about that, isn't there? Even the stars get separated from their families. Even the sun might have a sibling it lost track of a long time ago. And it doesn't make the sun sad. It just keeps shining, keeps warming us, keeps turning around the galaxy the way it always has. Whatever it lost, it's still here, still glowing, still ours. And somewhere, maybe, its twin is doing exactly the same thing for some other corner of the sky. Now I want to take you somewhere much stranger and much denser, and I promise even this one is calming if you hold it right. I want to talk about neutron stars, and specifically about how unbelievably, almost impossibly heavy their material is. So here's the setup. We talked about the gentle deaths of stars like our sun, the ones that fade into white dwarfs. But bigger stars, much bigger ones, go out differently. They collapse and explode in a supernova, one of the most violent events in the entire universe. And in the heart of some of these explosions, something extraordinary gets left behind. The core of the star gets crushed inward by its own gravity, squeezed so hard that the atoms themselves can't survive. The empty space inside atoms, and atoms are mostly empty space, remember, gets crushed right out of existence. Electrons get pushed into protons, and what's left is a star made almost entirely of neutrons, packed together with no gaps at all. We call it a neutron star, and a neutron star is small. We're talking about an object that might be only a dozen miles across, about the size of a city. You could drive across a neutron star in 20 minutes, if it weren't, instantly lethal in about 1,000 ways. But here's the thing. That city-sized object contains more mass than our entire sun. All the mass of a star, more massive than the sun, crushed down into a ball the size of a town. alone. The density is almost beyond imagining. So let me give you the image that really makes it land. And it's a gentle one, weirdly, a raindrop. Picture a single raindrop. Now imagine that raindrop, that tiny little drop of water, was filled with neutron star material instead. Just that one raindrop's worth. That single drop of neutron star matter would weigh more than Mount Everest, more than an entire mountain. The whole towering mass of the tallest mountain on Earth, packed into a space smaller than your fingertip. A raindrop heavier than Everest. Matter crushed so hard, so completely, that physicists describe it as becoming almost nothing but gravity, nearly pure gravity. It's stripped down past atoms, past structure, past almost everything we think of as stuff, into something that is basically the densest, purest expression of weight in the universe. And here's the part that I think is quietly beautiful. All that crushing, all that unimaginable violence and pressure, and the result is something perfectly still. A neutron star isn't thrashing around. It's just sitting there, spinning quietly in the dark, holding within it a density so extreme that a thimbleful would outweigh all of humanity combined. The most intense thing in the universe, and it's perfectly calm, perfectly silent. And I want you to sit with that contrast for a moment, because there's a kind of peace in it. The universe took one of its most catastrophic events, a giant star exploding, and what it left behind in the aftermath was something so dense it might as well be eternal, stable, unmoving. A neutron star will sit there, spinning slowly down, for an almost unimaginable span of time. Long after our sun has died, long after the Earth is gone, that little crushed city of pure gravity will still be out there, turning gently in the dark. There's a strange comfort in knowing the universe builds things that permanent, that even out of the loudest violence, it makes something that just rests. Now, here's the crazy part about neutron stars that makes them even softer than they sound. The surface of a neutron star is thought to be impossibly smooth. The gravity is so intense that any bump, any hill, any mountain on its surface would be flattened down to almost nothing. The tallest peak on a neutron star might be a few millimeters high. The whole surface is pulled into a sphere smoother than anything humans have ever made. So you've got this object, born from cataclysm, made of crushed matter heavier than a mountain per raindrop, and it's also one of the smoothest, most perfectly rounded things in all of existence. A flawless little sphere gliding silently through space. The universe really does have a way of turning its most violent moments into something almost serene. Now let me shift us to light again, because there's a phenomenon out there so gentle and so poetic that it sounds made up, and yet it's one of the most well-established things in modern astronomy. It's called gravitational lensing, and I want you to picture it slowly with me. Here's the idea. Einstein figured out that gravity isn't really a force pulling things the way we usually imagine it. Instead, mass bends space itself. A heavy object, a star, a galaxy, a cluster of galaxies, actually warps the space around it, like a heavy ball sitting on a stretched sheet, making a dip, and anything moving through that warped space, including light, has to follow the curve. So when a beam of light from a distant object passes near something massive, the light doesn't go straight, it bends. It follows the curve of warped space gently around the massive object and continues on its way. Now here's where it becomes magic. Imagine a faraway galaxy, far behind a huge cluster of galaxies from our point of view. The light from that distant galaxy comes toward us, but it has to pass that massive cluster in the middle, and the cluster's gravity bends the light. It bends it around itself, like a lens. That's why it's called gravitational lensing. The massive object acts like a giant lens in space, focusing and bending the light of whatever is behind it. And because the light can bend around different sides of the massive object, sometimes we see the same distant galaxy more than once. The light took different paths, one curving around the left, one around the right, one over the top, and all those paths reached us. So we see multiple images of the same single object spread across the sky. Sometimes it's smeared into a glowing arc. Sometimes, if the alignment is just perfect, it forms a complete ring of light around the massive object, called an Einstein ring. The same galaxy, wrapped all the way around in a circle, because its light got bent evenly in every direction on its way to us. But here's the part that I find genuinely moving, and it's the most relaxing version of this whole idea. Because the different paths the light takes are different lengths, the light arrives at different times. So astronomers have actually seen the same exploding star, the same supernova, appear more than once. They watched a star explode, its light reaching us by one bent path. And then, later, the same explosion appeared again, in a different spot, because the light that took the longer way around finally arrived. The same event, seen twice, separated by the time it took light to travel two different curving roads through warped space. Think about that. Light from a single explosion, billions of years ago, set out across the universe. Some of it took a shorter path, some took a longer one, bent around a massive galaxy in the middle, and both beams kept going, patiently, for all that time, until they reached us, one arriving, and then the other, the straggler, the one that took the scenic route, finally showing up to deliver the same message. Light that got lost on the long way around, and still found its way home. There's something so tender about that to me. The universe is so vast, and light has to cross such incomprehensible distances that some of it gets pulled off course, sent on a longer journey around the great curving valleys of warped space. And it doesn't get lost forever. It doesn't vanish. It just takes the long way, patiently, and it still arrives. Still carrying its picture of an event that happened before the Earth existed. The cosmos bends the path, stretches the journey, and the light makes it anyway. Every photon eventually gets where it's going, even if space itself tries to send it the long way around. And you know, when you really sit with gravitational lensing, it tells you something quietly reassuring about the universe. Nothing is truly straight out there, and yet everything still connects. Light from the dawn of time still finds its way to a single eye, a single telescope, a single quiet night on a small blue planet. The bending of space isn't a barrier, it's just a longer road. And the light is endlessly patient. It has nowhere else to be. It just travels and curves and arrives. Now here's something I want you to feel in your own body as you lie there, because it's happening to you right now, this very second, and it's one of the most peaceful, strange facts in all of science. As you're resting, trillions of dark matter particles are passing straight through your body every single second, silent, traceless. You can't feel them, you'll never feel them, and yet without them, the galaxies would fly apart. Let me explain what dark matter even is, because it's one of the gentlest mysteries we've got. When astronomers look at galaxies, they notice something that doesn't add up. Galaxies spin, and they spin so fast that, by all the rules of gravity we understand, they should be tearing themselves apart. The stars on the outer edges are whirling around so quickly that the gravity from all the visible stuff, all the stars, all the gas, everything we can see, simply isn't enough to hold them in. By rights, those outer stars should go flinging off into space, and the whole galaxy should unravel like a spinning top coming loose. But they don't. Galaxies hold together beautifully. Something is providing the extra gravity, the extra glue to keep them whole. And we can't see it. We can't detect it with any telescope. It doesn't give off light, doesn't absorb light, doesn't interact with light at all. We only know it's there because of its gravity, because of the way it holds galaxies together. We call it dark matter. And here's the staggering part. There's far more of it than there is of everything we can see. The ordinary matter, all the stars and planets and gas and dust and you and me and everything we've ever observed, makes up only a small fraction of the universe's matter. The vast majority is this invisible, silent, dark matter. The stuff we can see is the minority. The cosmos is mostly made of something we can't even touch, and it's everywhere. It's not just way out in the galaxy's edges. It's here. It flows through our entire solar system, through the Earth, through the room you're in, through you. Scientists estimate that trillions of dark matter particles are streaming through your body every single second, all the time, day and night. They pass through you the way you'd pass through a beam of light, without touching, without disturbing, without leaving the faintest trace. Right now, an invisible river of the universe's most abundant substance is flowing straight through your chest, and you feel absolutely nothing. Total silence, total stillness. The most common matter in the cosmos, passing through you like you're not even there. Now think about what that means, gently. The very thing that holds entire galaxies together, the invisible scaffolding that keeps the Milky Way from flying apart, is passing through your fingertips as you lie still. You are being threaded constantly by the same mysterious substance that cradles 100 billion stars. The glue of the galaxy is in the room with you. It's in you, and it asks nothing, disturbs nothing, just flows on through, silent and weightless, holding the universe together while you rest. There's a deep peace in that, I think. We spend so much time feeling separate from the cosmos, like it's something far away that we look up at. But you are not separate from it. You are sitting in the middle of it. It's flowing through you. The oldest light is landing on you, and the dark matter that holds the galaxies is streaming through you, and you're part of the same vast, quiet system as the rogue planets and the diamond worlds and the lost twin of the sun. You're not looking at the universe from the outside. You're inside it, made of it, woven through with it, right now. And here's a tender little thought to rest on with the dark matter. It's been doing this the whole time. Every second of your life, awake or asleep, those trillions of particles have been passing through you, faithfully, silently, while you were born, while you grew up, while you've laughed and worried and dreamed. This invisible substance has been quietly flowing through you the entire time, never once making a sound, never once asking to be noticed. The universe has been holding you, in a way, without you ever feeling its hands. Now let me drift us back out into the bigger picture for a moment, because I want to return to those rogue planets we started with and add something to them. We said there might be more sunless worlds than stars in the galaxy. And I want you to picture the scale of the darkness they drift through, because the emptiness between the stars is its own kind of soft, vast wonder. The distances out there are almost gentle in how enormous they are. The nearest star to our sun is a little over 4 light years away. That means the light leaving that star takes more than 4 years to reach us, traveling at the fastest speed anything can go. And between here and there is essentially nothing. Empty space, a vast, calm, dark ocean with no shore. If you shrank the sun down to the size of a grain of sand, the nearest other grain of sand, the nearest star, would be miles away. That's how empty it is out there. The stars are not crowded together. They are scattered across an immense, peaceful darkness, each one alone, each one separated from its neighbors by gulfs of quiet emptiness so wide they're hard to even picture. And the rogue planets drift through all of that, through the great quiet between the stars. They don't experience it as lonely, of course. They don't experience anything. They just glide, in no hurry, through the soft dark, in a silence so complete and so total that it's almost holy. No sound travels in space. there's nothing to carry it. So the whole vast drama of the cosmos, exploding stars, spinning neutron stars, colliding galaxies, all of it happens in perfect silence. The most violent events in the universe make no sound at all. There is no roar to the Big Bang in your ears, no thunder to a supernova, just silent light traveling through silent dark. And I find that one of the most relaxing facts of all, the universe is the quietest place there is. For all its size, all its energy, all its fire and motion, it makes no noise. The stars burn silently, the galaxies turn silently, the planets, sunless or not, drift silently. It is the most enormous, most peaceful silence imaginable, stretching out in every direction, forever, and tiny pinpricks of light cross that silence, patiently, taking thousands and millions and billions of years to travel from one quiet place to another. Now here's something gentle to think about with all that emptiness. You might assume all that empty space is cold and dead and meaningless, but that emptiness is exactly what makes the light possible. If space were crowded, if it were full of dust and matter everywhere, light couldn't cross it. We'd be back in that early universe fog, blind and trapped. It's the emptiness, the vast, quiet, patient emptiness between the stars that lets the oldest light travel all the way to us. It's the silence that lets the message through. The darkness isn't the absence of something. It's the very thing that makes seeing possible at all. Without all that gentle nothing in between, you couldn't see a single star. So the next time the size of it all feels overwhelming, all those light years, all that empty dark, try holding it the other way. That emptiness is what connects us. That silence is what lets the light arrive. The gulfs between the stars aren't keeping us apart from the cosmos. They're the roads that the cosmos travels to reach you. Let me come back now to that oldest light one more time, because there's a detail in it I didn't tell you yet, and it's one of the softest of all. When astronomers map the cosmic microwave background, that faint afterglow of the Big Bang coming from every direction, they find that it's almost perfectly smooth, almost. The temperature of that ancient glow is incredibly even, all across the sky, varying by only the tiniest fractions. The early universe was astonishingly uniform, astonishingly calm, a gentle, even glow with just the faintest ripples in it. But those faint ripples, those tiny variations, smaller than you could ever notice, those turned out to be the most important thing of all. Because in the places where the early universe was just a little bit denser, gravity had just a little more to pull on. And over billions of years, those tiny ripples grew. The slightly denser spots pulled in more material, and more, until they became the gas clouds that became the stars that became the galaxies. Everything you see in the night sky, every star, every galaxy, every world, grew out of those faint, almost invisible ripples in the afterglow of the beginning. The whole structure of the universe, all of it, was seeded by gentle little variations in that ancient, almost smooth light. So when you look at the cosmic microwave background, you're not just looking at the oldest light, you're looking at the seeds of everything, the faint blueprint from which all the galaxies grew. It's like looking at a baby picture of the entire universe, taken when it was only 380,000 years old, and being able to see, in the tiniest ripples, the first hint of everything that was going to be. The stars hadn't formed yet, the planets hadn't formed yet, you were nowhere in it, and yet it was all already there, written faintly into the glow, waiting to unfold. There's such a quiet wonder in that. The universe started out almost perfectly smooth and calm, and out of its tiniest imperfections, everything was born. The little flaws in the early glow weren't mistakes. They were the beginning of structure, the beginning of stars, the beginning, eventually, of you. Everything that exists came from gentle ripples in an ancient, even light. The whole magnificent, complicated cosmos grew out of something almost perfectly serene. Now let me return us to the diamond worlds and the dead stars for one more soft thought, because the way stars die is itself a kind of lullaby when you look at the long arc of it. We tend to think of death as an ending, full stop, but stars don't really end, they transform. A star like our sun spends billions of years shining, gently fusing hydrogen into helium, warm and steady. And when it finally runs low on fuel, it doesn't just blink out. It swells up into a vast, glowing red giant, soft and enormous. And then it gently sheds its outer layers, blowing them off into space in a beautiful, glowing shell of gas called a planetary nebula. Some of the most beautiful objects in the entire sky are these dying stars, exhaling their outer layers in delicate, colorful rings and clouds. Death, in the cosmos, can be one of the most gorgeous things there is. And then, at the center of that beautiful exhaled cloud, the leftover core remains, the white dwarf we talked about, and it begins its long, long cooling. Over billions and billions of years, it slowly fades, slowly cools, perhaps slowly crystallizing into diamond, as we said. But here's the thing, it never really disappears. It just gets quieter and dimmer and calmer, fading toward a deep, dark stillness over a span of time so long that the universe isn't even old enough yet for any white dwarf to have fully gone cold. Not one. Every white dwarf that has ever formed is still out there, still gently glowing, still slowly cooling. The universe simply hasn't had enough time for any of them to finish dying. And that gas that the dying star blows off into space, that beautiful exhaled cloud, doesn't go to waste either. It drifts out into the galaxy, enriched with the elements the star made during its life. Carbon, oxygen, all the ingredients. And eventually that gas can become part of a new cloud, a new stellar nursery, where new stars and new planets are born. The death of one star quite literally seeds the birth of the next. The material gets recycled, passed on, used again. Nothing is truly lost. The atoms that made an ancient star become the atoms of a new one, and someday, maybe, the atoms of a world, and the atoms of living things on that world. In fact, this is the gentlest, truest thing I can tell you tonight. The carbon in your body, the oxygen you're breathing right now, the iron in your blood, the calcium in your bones, all of it was made inside stars, forged in the hearts of stars that lived and died long before our sun was born. Those stars made these elements, and then they died and blew them out into space, and that material drifted through the galaxy and eventually gathered together to form our sun, our Earth, and you. You are made of the ash of dead stars. Every atom in your body, other than the very lightest ones, was cooked inside a star and scattered by its death. You are, quite literally, stardust, gathered up and given a little while to look back up at the sky you came from. So when you look at a dying star, at a white dwarf, at a glowing nebula, you're not really looking at an ending. You're looking at the same process that made you, the same gentle cycle of birth and death and rebirth that built every atom you're made of. The stars die so that worlds can be born. And the worlds give rise, eventually, to someone who can lie back and look up and feel calm and understand just a little of where they came from. That's you, tonight, made of stardust, resting under the same sky that made you. And that brings us back in a gentle circle to where we started. To the rogue planets drifting alone in the dark, each one made of that same recycled stardust, each one a world with its own story, its own mountains, its own hidden possibilities. There may be more of them than there are stars, trillions of quiet worlds gliding through the soft, silent dark, carrying their frozen oceans and their secret warmth in a night that never ends. And there's nothing sad about them. Not really. They're just part of the vast, calm, patient machinery of the cosmos, doing what the cosmos does, drifting, turning, cooling, glowing, recycling, beginning again. The universe is enormous beyond comprehension. It's mostly empty, mostly silent, mostly dark. The stars are scattered impossibly far apart. There are worlds with no suns, and suns with lost twins, and planets made of diamond, and matter so dense a raindrop outweighs a mountain. And all of it, every bit of it, is unfolding right now, in perfect quiet, all around you, and through you, and as you. The oldest light is arriving. The dark matter is flowing. The stardust that makes you is the same stardust that makes everything else. You are small, yes, wonderfully, peacefully small. A tiny gathering of ancient atoms lying still under an enormous, gentle sky. And that's not a frightening thing to be. It's one of the most relaxing things there is. So just rest there for a while longer and let the bigness of it all hold you, the way the dark matter holds the galaxies, silently, invisibly, faithfully. There's so much more out there, drifting in the quiet dark, waiting to be felt, and we've only just begun to drift through it. Now, let me take you somewhere even bigger and even quieter, because there's a thing that happens to galaxies that I think is one of the most peaceful ideas in all of astronomy, even though it sounds like it should be terrifying. Galaxies collide. They crash into each other, and our own Milky Way is going to do it. In about 4 billion years, our galaxy is going to merge with our nearest big neighbor, the Andromeda Galaxy, which is hurtling toward us right now, getting closer every second. And you'd think that would be the most catastrophic thing imaginable, right? 2 entire galaxies, each with hundreds of billions of stars, smashing into each other head-on. You'd picture stars colliding everywhere, explosions, total chaos. Well, here's the part that's going to surprise you, and it's genuinely one of the most calming facts I know. When 2 galaxies collide, almost no stars actually hit each other. Basically none. 0 in most cases. Let me explain, because this one is beautiful. Remember how empty space is. Remember how we said if you shrank the sun to a grain of sand, the nearest other grain of sand would be miles away. Well, that's the secret. Galaxies are mostly empty space. The stars inside them are so incredibly far apart, with such vast gulfs of nothing between them, that when 2 galaxies pass through each other, the stars just slide past one another. They glide by in the dark, separated by light years, like 2 enormous, sparse swarms of fireflies drifting through each other on a summer night. The galaxies pass through one another, their shapes pulled and stretched by gravity into long, graceful arcs, but the individual stars almost never touch. The collision happens in slow motion, over hundreds of millions of years, silent and smooth, and your own descendants, if there were any, could stand and watch the whole thing unfold across the sky, without ever being in danger from a single colliding star. Think about that. 2 galaxies, each holding hundreds of billions of suns, can pass straight through each other, and the stars are so widely scattered that they barely notice. The emptiness that we talked about, that vast, quiet dark between the stars, it's so enormous that it cushions everything. It turns what should be the most violent event imaginable into a slow, graceful, almost gentle dance. The galaxies merge over an unimaginable span of time, eventually settling into one new, larger galaxy, all without the cosmic carnage you'd expect. Just 2 great clouds of stars swirling slowly together, finding a new shape over billions of years. And by the time it happens, our sun will be old. The Earth as we know it will likely be long changed, but the sun itself will probably still be out there, somewhere in the merging swirl, carried along gently by the new gravity, finding a new place in a new galaxy. Astronomers have even given the future merged galaxy a name. They sometimes call it Milkomeda, a blend of Milky Way and Andromeda. A new galaxy, born from the slow, quiet union of two old ones, 4 billion years from now. And our sun will be part of it, drifting into a new home it never chose, in the most unhurried collision you could possibly imagine. There's something so reassuring in that to me. The thing that sounds like the ultimate catastrophe turns out to be one of the gentlest events in the universe. Because space is so vast and so empty, even galaxies crashing together do it tenderly. Nothing breaks, nothing shatters. The stars just rearrange themselves, slowly, over hundreds of millions of years, into a new pattern. The universe doesn't destroy, it mostly just reshuffles, patiently, on timescales so long that the word collision starts to feel like the wrong word entirely. It's more like a merging, a coming together, two galaxies that drift into each other's arms and slowly become one. Now, speaking of slow timescales, let me give you one of the most mind-stretching and oddly soothing facts about time itself out there in the cosmos. You know that light takes time to travel. We talked about that. The nearest star is over 4 light years away, which means you're seeing it as it was 4 years ago. But here's the thing that follows from that, and it's gentle and strange all at once. When you look up at the night sky, you are not seeing the universe as it is now. You are seeing the past, all of it. Every single point of light in the night sky is a window into the past, showing you light that left its source years or centuries or millennia or even millions of years ago. Let me explain how deep that goes. When you look at the sun, well, don't look right at it. But when its light reaches you, you're seeing it as it was about 8 minutes ago, because that's how long sunlight takes to cross the gulf to Earth. When you look at the bright star Sirius, you're seeing light that left it about 8.5 years ago. When you look at some of the stars in famous constellations, you might be seeing light that left them hundreds of years ago, back before your grandparents' grandparents were born. And some of those stars, this is the gentle, wistful part, some of them may not even exist anymore. They may have died long ago, while their final light was still crossing the immense dark to reach your eyes. You could be looking at a star that's already gone, still shining in your sky, a ghost of light from something that ended before you were born. Now here's why that's not sad. Not really, because it means the night sky is a kind of memory. It's the universe remembering itself. Every star you see is a moment preserved in light, carried faithfully across the dark to be witnessed by you tonight, even if the star that made it has long since changed. The sky is a museum of light, where every exhibit is a different age, all displayed at once. When you look up, you're not looking at a single moment. You're looking at thousands of different moments, layered together, light from 8 minutes ago, 8 years ago, 800 years ago, all reaching your eyes in the same quiet instant. The whole history of the nearby universe, gathered into one peaceful glance upward. And when you look at the faint, fuzzy smudge of the Andromeda Galaxy, the one that's going to merge with us someday, you're seeing light that left it about 2.5 million years ago. 2.5 million years. That light set out when our ancestors were just beginning to walk upright on the plains of Africa, long before anything you'd recognize as a human existed. It crossed the immense dark for all that time, patiently, and it's only landing on you now, tonight. The oldest thing you can see with your naked eye, and it traveled across more than 2 million years of darkness just to arrive in your eye on this quiet night. There's something so tender about that. The universe sends its light out, and it takes its time, and eventually it finds someone who's willing to look up and receive it. Now let me bring it back down a little closer to our own neighborhood. because there's a place in our solar system that I think is the most peaceful, dreamlike spot in the whole sky, and it's a moon, not our moon, a moon of Saturn called Titan. And Titan is one of the gentlest, strangest worlds we know of, and I want you to picture standing on it with me for a moment. Titan is the second largest moon in the whole solar system, bigger than the planet Mercury, and it's the only moon we know of with a thick atmosphere, a real dense, hazy atmosphere, even thicker than Earth's. So thick and so hazy, in fact, that you can't see the surface from space at all. Titan is wrapped in a soft, orange, golden haze, a permanent, gentle smog of organic chemistry that hides everything below it. For a long time, we had no idea what was under there. It was a mystery, a moon shrouded in a warm orange glow, hiding its face from us. And then we sent a probe down through that haze, and what we found is one of the most beautiful and unexpected things in the solar system. Because on Titan, it rains. There's weather. There are clouds and rain and rivers and lakes and even seas. But here's the thing. It's far too cold on Titan for water. The water there is frozen harder than rock. So what falls as rain and what fills the rivers and the lakes and the seas isn't water at all. It's liquid methane and ethane. Liquid natural gas, basically, falling as a slow, gentle rain through that thick golden air, pooling into lakes and seas on the surface. Picture that with me. You're standing on Titan. The gravity is gentle, much weaker than Earth's, so you feel light, almost floating. The sky above you is a soft, hazy orange. The sun just a dim glow filtered through the thick haze, giving everything a warm, dim, golden twilight that never quite becomes day and never quite becomes night. And it's raining, slowly. The drops fall gently, lazily, because the air is so thick and the gravity is so weak that raindrops on Titan drift down slowly, almost in slow motion, much more gently than they fall on Earth. Soft methane rain, drifting down through golden haze onto seas of liquid gas in a world wrapped in permanent quiet twilight. It might be the most serene place in the entire solar system. And those seas are real, by the way. There's a sea on Titan, near its north pole, that's larger than any of the Great Lakes on Earth. A vast, calm sea of liquid methane, sitting under the orange sky, with gentle waves, tiny, slow waves, because everything on Titan moves gently. We've even detected the ripples on its surface. A whole alien sea, calm and cold and quiet, on a moon nearly 1 billion miles away. And it just sits there, in the soft, golden dark, with its slow rain falling and its slow waves lapping, completely undisturbed, exactly as it has been for who knows how long. There's something so dreamlike about Titan. It's familiar and alien at the same time. It has weather and rivers and lakes and seas, just like Earth, but made of something completely different, lit by a soft orange glow, drifting in slow motion. It feels like a memory of Earth seen through a dream, gentle and hazy and strange, and it's a real place. You could, in principle, stand on its shore and watch the methane rain fall on a methane sea under an orange sky. Of all the worlds out there, Titan might be the one that feels most like a lullaby made solid. Now, here's the crazy part about Titan that makes it even more wonderful. Because Titan has all this complex organic chemistry, all these carbon-based molecules raining down and pooling in its seas, some scientists wonder whether some strange, exotic form of life could exist there. Not life like ours, that needs liquid water, but maybe some completely different kind of chemistry. Some life that uses liquid methane the way we use water. We don't know. It's an open question. But just the possibility is gentle and wonderful. That on this quiet, hazy, twilight moon, with its slow rain and its slow seas, there could be something we've never imagined, living in the cold and the dark, in its own slow, patient way. Even there, even in that distant golden twilight, the universe might be quietly keeping the door open for life. Now, let me take you to the opposite extreme for a moment, because I want to show you something about how the universe handles even its most extreme objects with a strange kind of calm. I want to talk about black holes. And I know, black holes have a reputation. They're supposed to be terrifying, the monsters of the cosmos, devouring everything, ripping things apart, the ultimate destroyers. But let me reframe them for you, gently, because the truth about black holes is much quieter and much stranger than the scary stories. First of all, a black hole is just a place where gravity has become so strong that not even light can escape it. That's the whole definition. It's a region where the pull is so intense that once something crosses a certain boundary, called the event horizon, it can't come back out, because to leave, it would have to travel faster than light, which nothing can do. So a black hole isn't really a thing, exactly. It's more like a place, a region of space where gravity has won completely. And here's the first calming thing. Black holes don't go around hunting. They don't suck things in from across the galaxy. They're not cosmic vacuum cleaners roaming the stars looking for prey. A black hole only affects things that come very close to it. If you replaced our sun with a black hole of the exact same mass, which would never happen, but just imagine, the Earth wouldn't get sucked in at all. It would keep orbiting exactly the same way it does now, because the gravity at our distance would be exactly the same. It would just get very, very dark and cold, because the sun's light would be gone, but the orbit would be perfectly stable. Black holes only pull you in if you get extremely close. From a distance, they're just like any other massive object, sitting there quietly, minding their own business. And here's the part that genuinely amazes me. At the center of almost every large galaxy, including our own Milky Way, there's a supermassive black hole, an enormous one, millions or even billions of times the mass of the sun. And ours has a name. It's called Sagittarius A star. And you'd think that having a giant black hole at the center of our galaxy would be a constant source of danger, but it's not. It just sits there at the very heart of the Milky Way, 26,000 light years away from us, quietly. The whole galaxy, all those hundreds of billions of stars, all of us, slowly turn around that central point, around that quiet, massive heart. The black hole isn't devouring the galaxy. It's more like the still center that everything else gently revolves around, the calm anchor at the middle of the great slow turning. Think about that for a second as you rest. The center of our galaxy, the point that everything circles, is one of the most extreme objects in the universe, and it's perfectly still and quiet, just sitting there, while 100 billion stars wheel slowly around it over hundreds of millions of years. We are, right now, very slowly orbiting that distant, silent center, carried along with all the other stars in a vast, graceful, unhurried circle that takes our sun about 230 million years to complete just once. One single trip around the galaxy takes more than 200 million years. The last time the sun was in this exact spot in its galactic orbit, dinosaurs were just beginning to appear on Earth. That's how slow and how grand the turning is. We are on the gentlest, longest carousel imaginable, riding around a quiet center, and we don't feel a thing. And here's one more soft idea about black holes that I love. They're not even permanent. The great physicist Stephen Hawking figured out that black holes very, very slowly leak away. They give off a tiny, faint trickle of radiation. We call it Hawking radiation. And over unimaginably long stretches of time, that trickle causes them to slowly shrink, and eventually, in the far, far future, to gently evaporate away entirely. Even black holes, the most extreme gravity wells in existence, don't last forever. They fade. Slowly, over timescales so vast they make the current age of the universe look like a single heartbeat, but they fade. Nothing out there is truly eternal. Everything is on a slow, gentle journey towards something else. Even the black holes will someday, quietly, be gone. There's a strange peace in that to me. The universe isn't a place of permanent monsters and eternal threats. It's a place where everything, even the most powerful things, is slowly changing, slowly drifting, slowly winding down or building up. The black holes evaporate, the stars die and are reborn, the galaxies merge. Everything is in gentle, patient motion, on timescales so long that violence becomes calm and destruction becomes transformation. There's nothing out there that's frozen in anger forever. It's all just flowing, slowly, quietly, toward whatever comes next. Now, let me come back to light one more time, because there's a phenomenon I want to share that is, I think, one of the most quietly poetic things in all of physics. We've talked about how light bends around massive objects, and how it takes time to travel, and how old it can be. But here's something about the light from the most distant galaxies that adds a whole new layer of gentleness. The light from faraway galaxies arrives to us stretched, reddened, softened, just like that ancient afterglow we talked about. Let me explain, because this ties everything together beautifully. The universe is expanding, has been, ever since the Big Bang. Space itself is gently stretching, growing, in every direction, all the time. And as space stretches, it stretches the light traveling through it. A wave of light that's set out from a distant galaxy gets its wavelength pulled longer and longer the further it travels, because the very space it's moving through is expanding beneath it the whole way. This shifts the light toward the red end of the spectrum, so we call it redshift. The further away a galaxy is, the longer its light has been traveling, the more space has stretched in the meantime, and the more its light is shifted toward red. So the most distant galaxies we can see, the ones from the early universe, billions and billions of light years away, have had their light stretched so dramatically that what started as ordinary visible light has been pulled all the way into the infrared, beyond what your eyes could even see. The light from the dawn of galaxies arrives to us softened, reddened, gentled by the expansion of the universe itself. The cosmos doesn't just send us light from the distant past. It tucks that light in, stretches it out, softens it on the long journey, so that the oldest, most distant light arrives to us as a gentle, low, warm glow. And this is how we know the universe is expanding, by the way. We look out, and we see that nearly every distant galaxy is redshifted, its light stretched, meaning it's moving away from us. And the farther away it is, the faster it seems to be receding. It's not that we're at the center of some explosion that everything is fleeing from. It's that space itself, everywhere, is gently expanding, carrying the galaxies apart from each other like dots drawn on a balloon that's slowly being inflated. Every galaxy sees every other galaxy drifting away. The whole universe is very gently, very slowly, growing larger, every moment, in every direction. The space between things is quietly increasing all the time, even right now, even in the room you're in, though on scales far too small for the local gravity of you and the Earth to ever let you notice. There's something so calm about that image to me. The universe isn't blowing apart violently. It's gently expanding, like a slow, deep breath that's been going on for 13 billion years and will go on for billions more. Everything drifting softly apart, making more room, more space, more quiet. The cosmos isn't tense, it's relaxing, it's unfurling, slowly opening up, giving everything a little more room to drift. Now here's a gentle thought that follows from the expansion, and it's a little wistful, but I think it's beautiful. Because the universe is expanding, and because the most distant galaxies are receding from us, there will come a time, far, far in the future, when those distant galaxies will have drifted so far away, and the space between us will have stretched so much, that their light will no longer be able to reach us at all. They'll fade from view, one by one, over billions of years, slipping beyond the edge of what we can ever see. The night sky of the very far future will be emptier than ours. Whoever might look up then, in galaxies yet to come, will see fewer lights than we do. Which means, and this is the tender part, we are living in a special time. A time when the universe is still young enough, still close-knit enough, that we can look out and see other galaxies. We can see the old light. We can read the universe's history written in the sky. We happen to exist at a moment when the cosmos is still legible, still full of visible neighbors, still telling its story to anyone who looks up. That's a gift, in a way. We arrived at exactly the right time to see it. Not too early, when the universe was a formless fog. Not too late, when its neighbors will have drifted out of sight. But right now, in the gentle middle, when the sky is full of light and full of stories, and there's someone here to look. Now let me bring you back home one more time, to something close and quiet and almost touchable. I want to talk about the moon, our moon, because even our oldest, most familiar companion has a soft secret you might not know. The moon is slowly drifting away from us, very, very slowly, about 1.5 inches per year, a little less than the rate your fingernails grow. The moon is gently spiraling outward, easing away from the Earth, a tiny bit farther every year, in a slow goodbye that will take billions of years to play out. It wasn't always so far away. Long ago, in the deep past, the moon was much closer to the Earth, and it loomed huge in the ancient sky, far bigger than the gentle silver disk we see now. And over billions of years, it has been gradually, patiently easing outward, settling into a wider and wider orbit, drifting away by inches, year after year, age after age. It's such a slow farewell that it's imperceptible in a human lifetime, but it's happening. Right now, tonight, the moon is a tiny fraction farther from you than it was last year, and it will keep going, gently receding, for as long as the Earth and moon endure. And here's the soft, wonderful coincidence that comes from where the moon is right now, in this particular era. The moon is about 400 times smaller than the sun, but the sun is also about 400 times farther away than the moon. And because of that, by pure cosmic coincidence, the moon and the sun appear almost exactly the same size in our sky. They look the same size to your eyes. And that's why we get total solar eclipses, those rare, breathtaking moments when the moon slides perfectly in front of the sun and covers it exactly, leaving just the soft, glowing halo of the sun's corona around a black disk. The moon fits over the sun almost perfectly, like a lid on a jar, because of this gentle, accidental matching of size and distance. But here's the wistful part, and it ties back to the drifting. Because the moon is slowly moving away, this perfect matching won't last forever. In the far future, the moon will be too far away to fully cover the sun, and total solar eclipses will no longer happen. They'll become a thing of the past, which means, and this is lovely to think about, we are living in the age of perfect eclipses. The moon happens to be at exactly the right distance, right now, in this slice of cosmic time, to fit over the sun just so. It wasn't always this way, and it won't always be this way, but it is now, in our era. We get to see the perfect eclipse. We arrived at exactly the right moment in the moon's long, slow drift to witness that perfect fit. Another gift of timing. Another way that we happen to be here at just the right time to see something beautiful. There's a pattern emerging in all of this, isn't there? The more you learn about the universe, the more it feels like we've arrived at a strangely perfect moment. The sky is still full of galaxies we can see. The moon is still at just the right distance for perfect eclipses. The sun is in the calm, steady middle of its life, shining gently and reliably. We exist in a window of cosmic time that is, in so many ways, just right for looking up and understanding. And maybe that's not a coincidence at all, but a simple truth that the universe had to be this calm, this stable, this gentle for long enough for someone like you to come along and be able to lie back and contemplate it. The calm came first. We came because of it. Now let me drift back out again, because I want to give you a sense of just how much there is and how that vastness, instead of being frightening, can be the most relaxing thought of all. We've talked about our galaxy, the Milky Way, with its hundreds of billions of stars. But the Milky Way is just one galaxy, and the universe is full of galaxies, just absolutely full of them. The best estimates suggest there are something like 2 trillion galaxies in the observable universe. 2 trillion. Each one containing tens or hundreds of billions of stars. The numbers get so large so fast that they stop meaning anything to the human mind, and you just have to let them wash over you. Let me try to give you one image that captures it. There was a famous moment when astronomers pointed the Hubble Space Telescope at a tiny, seemingly empty patch of dark sky. A patch so small you could cover it with a grain of sand held at arm's length. A spot that, to the naked eye, was just empty black nothing. And they left the telescope staring at that tiny dark patch for a long time, gathering every faint photon. And when the image came back, that tiny, empty-looking speck of sky was full of galaxies. Thousands of them. Thousands of entire galaxies, each with billions of stars, all crowded into a patch of sky the size of a grain of sand, held at arm's length, in a spot that had looked completely empty. And that's true. Everywhere you look, every empty seeming patch of the night sky is, if you look deep enough, packed with galaxies, stretching back almost to the beginning of time. Now that could feel overwhelming. It could make you feel impossibly tiny, lost, insignificant. But I'd ask you to hold it the other way, gently, because that vastness means the universe is endlessly rich, endlessly deep. No matter how much we explore, there is always more. There is more wonder out there than could ever be exhausted, more worlds and more light and more strangeness than all the generations of humanity could ever finish discovering. The universe is not a small, finished thing that we'll someday figure out completely. It's an endless, deep, gentle ocean of wonder, and we get to swim in just a little of it, and there is always, always more. And in all those 2 trillion galaxies, in all those countless hundreds of billions of stars each, with all their planets and all their rogue worlds drifting between them, somewhere in all of that incomprehensible vastness, here you are, one person, lying still on one small world, around one ordinary star, in one ordinary galaxy, looking up and feeling calm. And there's something almost miraculous about that, isn't there? In all that vast, silent, drifting cosmos, there's a little corner where the universe woke up enough to look back at itself, to feel wonder, to feel peace. That's you. That's what you are. The universe, in one small, quiet place, becoming aware of its own beauty. Now let me share a fact about that very awareness, because it's gentle and it brings the cosmos right inside you again. Every atom in your body, as we touched on before, was made in stars. But let me make that even more intimate. The iron in your blood, the iron that carries oxygen through your veins right now as you breathe slowly and rest. That iron was forged in the heart of a dying star, in the final moments before it collapsed and exploded. Iron is special because it's one of the last things a massive star can make before it dies. And when that star exploded, it scattered that iron across space, and billions of years later, some of it ended up here, in you, doing the quiet work of keeping you alive. The same element born in a stellar death is, right now, moving through your heart with every beat. And the calcium in your bones, the structure that holds you up as you lie there, also made in stars. And the oxygen filling your lungs as you take a slow breath, made in stars. You are not separate from the cosmos we've been drifting through tonight. You are a piece of it, gathered up and given form and given, for a little while, the ability to feel and to think and to wonder. When you look up at the stars, it's really stardust looking back at the place it came from. There's no separation. The thing observing and the thing observed are made of the same ancient material. You are the universe, taking a moment to marvel at itself and then to rest. Let me give you one more gentle fact to settle into before we drift further, and it's about silence again, but in a new way. We talked about how space is silent because sound can't travel through the emptiness. But here's a beautiful exception, a quiet exception that astronomers found. In the center of a distant cluster of galaxies, there's a supermassive black hole, and the gas around it is being disturbed in a slow, rhythmic way that creates pressure waves rippling out through the thin gas of the cluster. And those pressure waves are, technically, sound, a sound rippling out through space. Astronomers worked out the pitch of that sound, and it's a note, a single, impossibly deep note, far, far below anything a human could ever hear, about a B flat, but 57 octaves below the lowest note on a piano. The deepest note in the known universe, a slow, vast hum, rippling out from a black hole across hundreds of thousands of light years. Think about that. There's a sound out there, the lowest note ever detected, droning slowly through the cosmos, far too deep for any ear, rippling out from millions of years across the dark. The universe is humming quietly, in a register so low that it's almost stillness itself. A deep, slow, endless note played by a black hole in a key no one can hear. If the cosmos has a lullaby, maybe that's it. A single deep tone, 57 octaves below the bottom of the piano, holding steady across the ages, soft and slow and eternal. And you know, that idea that the universe might have a kind of hum, a kind of song too deep and too slow for us to hear, feels like a fitting thing to rest on for a while. Because so much of what we've drifted through tonight is like that. Vast, slow, gentle processes happening just beyond the edge of our perception. The moon easing away by inches. The galaxies drifting apart on a 13 billion year breath. The sun carrying us around the galaxy on a 200 million year carousel. The old light arriving, the dark matter flowing through you, the deep note humming across the void. All of it slow, all of it quiet, all of it utterly indifferent to hurry. The universe has all the time there is, and it spends it gently. And here you are, in the middle of all of it. Small, yes, but woven into it completely. Made of its oldest material, warmed by one of its stars, carried along on its slow turning, threaded through with its invisible substance, watching its ancient light arrive in your eyes. You don't have to do anything. You don't have to hurry. The cosmos certainly isn't hurrying. It's been drifting, patiently, peacefully, for 13 billion years, building diamond worlds and rogue planets, and humming black holes in the iron in your blood, all without a sound, all without a rush. And tonight, you get to be a small, quiet part of that, just lying still, just breathing slowly, just letting the bigness of it all hold you gently in the dark. There's so much more out there still drifting in the quiet, so many more soft and strange truths waiting in the dark. So stay with me a little longer, and let's keep drifting through the gentlest corners of the cosmos together. Now, let me drift us towards something that's hanging right above your head in the night sky, something you've probably seen 1,000 times without realizing what you were really looking at. That hazy band of soft light that arcs across the sky on a dark night, away from the city, that pale, milky river of glow. That's the Milky Way. That's our own galaxy, seen edge on from the inside. And here's the gentle, strange truth of it. When you look up at that band of light, you're looking through the flat disk of the galaxy you live in. edgewise, at the combined glow of hundreds of billions of stars, too far and too faint to see one by one, all blurred together into a single soft ribbon of light. We live inside a galaxy. That's such an easy thing to say and such a hard thing to really feel, but it's true. The Milky Way is a vast, flat, spinning disk of stars, and our sun is tucked out in one of its spiral arms, about halfway from the center to the edge, in a quiet, unremarkable, perfectly pleasant suburb of the galaxy. And from our spot inside that disk, when we look toward the crowded center of it, we see all those distant stars blending together into that pale river arcing overhead. The ancient peoples who named it saw a river of milk spilled across the sky. And basically that's exactly what it is. The light of our own home galaxy, seen from within. A glowing wheel of stars that we happen to live inside. Now here's something that I find quietly humbling and lovely at the same time. Our spot in the galaxy is so calm. We're out in the quiet outskirts, away from the dense, crowded, busy center. And that's actually really fortunate for us, because the center of the galaxy is a far more chaotic place. Stars packed close together, more radiation, more gravitational disturbances. Out here, in our peaceful little corner of a spiral arm, things are gentle and stable. The stars are spread far apart. The sun gets to drift along quietly, undisturbed, for hundreds of millions of years at a time, giving life on Earth the long, calm stretches it needed to develop. We live in the gentle suburbs of a gentle galaxy, and that calm is part of why we're here at all. And as we said before, we're slowly turning around that distant center, all of us together, the whole spiral arm gliding along. But here's a detail that makes it even softer. The sun doesn't just circle the center of the galaxy in a flat, simple loop. As it goes around, it also gently bobs up and down through the plane of the galactic disk, like a horse on a carousel that rises and falls as it goes around. Over tens of millions of years, the sun slowly drifts up above the central plane of the galaxy, then slowly sinks back down through it, then drifts below, then rises again. A gentle, slow, vertical bobbing as it makes its long circuit. We are, very slowly, riding up and down on the cosmic carousel as we go around. A motion so gradual, you could live 10,000 lifetimes and never sense it. The galaxy carries us in a slow, looping, bobbing dance, and we feel perfectly still the whole time. Now, speaking of feeling still while moving, let me give you one of the most mind-bending and yet oddly peaceful facts about your own situation right now. Lying there, perfectly motionless. You are not motionless at all, not even close. Right now, as you rest, the Earth is spinning on its axis, carrying you around at hundreds of miles per hour just from the rotation. At the same time, the Earth is hurtling around the Sun at about 67,000 miles per hour. At the same time, the Sun, carrying the whole solar system with it, is racing around the galaxy at something like 500,000 miles per hour. And on top of all that, the entire Milky Way galaxy is itself moving through space, drifting toward other galaxies at hundreds of thousands of miles per hour more. So right now, lying perfectly still, feeling completely at rest, you are actually moving through space at an absolutely staggering speed. Layered motion upon motion upon motion, spinning, orbiting, racing around the galaxy, drifting through the cosmos. You are one of the fastest moving things you can imagine, and you feel nothing. Total stillness, perfect calm, because all that motion is smooth and steady and unchanging. Your body has no way to feel it. There's no wind, no jolt, no rush, just the quiet sensation of lying still, while in truth you're flying through the universe at 500,000 miles an hour and more. And I think there's something deeply soothing in that. Once you sit with it, you don't have to do anything to be part of the great motion of the cosmos. You're already in it. You're already flying, already orbiting, already turning, already drifting along with the galaxy. The universe is carrying you effortlessly, gently, whether you're awake or asleep, whether you're trying or resting. You can be completely, perfectly still, and the cosmos will still carry you halfway across the galaxy over the course of your life, without you ever lifting a finger. You're being carried. You always have been. You can just let it. Now, let me take you to one of my favorite quiet places in the whole solar system, a place of almost unbelievable gentleness, and it's the rings of Saturn. You've seen pictures, I'm sure, those magnificent sweeping rings encircling the golden planet. But let me tell you what they're actually made of, because it's softer and stranger than you might think. Saturn's rings are made of countless billions of pieces of ice, just ice, chunks and particles of water ice, ranging in size from tiny grains smaller than a grain of sand, up to boulders the size of a house, all orbiting Saturn together in a vast, flat, shimmering sheet. And those rings are enormous in width. They stretch out hundreds of thousands of miles across, wider than many planets. But here's the part that astonishes me. For all their breadth, they are incredibly thin, unbelievably thin. In most places, Saturn's rings are only about 30 feet thick, top to bottom, 30 feet. A sheet of ice particles spread across hundreds of thousands of miles, and yet so thin that, relatively speaking, it's like a sheet of paper the size of a city. If you could shrink Saturn's rings down to the width of a football field, they'd be far thinner than the thinnest razor blade. They are, proportionally, one of the flattest, most delicate structures in the entire solar system. A vast, glittering, gossamer-thin disk of ice catching the distant sunlight, encircling a giant planet in perfect, silent balance. And those billions of ice particles are all just orbiting, gently, each one a tiny moon in its own right, following its own quiet path around Saturn, the whole thing turning together like a slow, sparkling record on a turntable. When sunlight hits them, they shimmer and glow, a soft band of light wrapped around the golden planet. And it's all completely silent, of course. Billions of pieces of ice, drifting in their slow orbits, never crashing, never falling, just circling, endlessly, in a delicate dance that's been going on for an immense span of time. There may be no more serene a sight in the entire solar system than Saturn, hanging in the black, wrapped in its thin, shining, silent rings of ice. And here's the wistful part, the part that makes them precious. Saturn's rings might not be permanent. Scientists think they may be relatively young, in cosmic terms, and that they might slowly fade away over the coming hundreds of millions of years, as the ice gradually rains down onto Saturn, pulled in by the planet's gravity. So once again, we may be living at a special time. A time when Saturn has its glorious rings, when there's something there to see. They may not have always been there, and they may not always be there, but they're there now, in our era, shining quietly in the dark for anyone who looks. The universe keeps giving us these gifts of timing, these beautiful things that exist right now, in the gentle window when we happen to be here to witness them. Now, let me bring you somewhere even more delicate, because I want to talk about the most empty, most perfect emptiness there is. We've talked about the emptiness between the stars and the emptiness between the galaxies. But let me tell you about the emptiest place we know of, a region called the Boötes Void. It's a vast, nearly empty bubble in space, an enormous region hundreds of millions of light years across, where there are almost no galaxies at all. Most of the universe, even in its emptiest stretches, has galaxies scattered through it. But the Boötes Void is so empty that if our own Milky Way were sitting at its center, we wouldn't have even known other galaxies existed until well into the 20th century, because there'd be almost nothing nearby to see. A bubble of near-perfect nothing, so vast that light takes hundreds of millions of years just to cross it, with only a tiny scattering of lonely galaxies drifting through all that emptiness. Now that might sound desolate, but picture it gently. Out there, in the heart of that great void, a galaxy drifts almost completely alone, with no neighbors visible anywhere, surrounded by hundreds of millions of light years of soft, quiet dark in every direction. And it doesn't mind. It just turns slowly, makes its stars, lives its long galactic life in the most profound solitude imaginable. There's a kind of monastic peace to it, isn't there? A galaxy in perfect quiet, with nothing to disturb it, drifting alone through the emptiest place in the cosmos, content in its solitude. Even the loneliest corners of the universe have their own deep calm. And this brings up something genuinely strange and beautiful about how the universe is arranged on the very largest scales. Because the galaxies aren't scattered randomly through space, like salt thrown across a table. They're arranged in a pattern, a vast, delicate, web-like pattern. Galaxies gather together into long, glowing filaments and threads, with great empty voids in between. And where the filaments cross, you get dense clusters of galaxies, like knots in a net. Astronomers call it the cosmic web, and if you could zoom out far enough to see the whole structure of the universe at once, it would look like an enormous three-dimensional spider web, or like the neurons in a brain, or like the roots of some vast tree, glowing threads of galaxies stretched across the dark, with great quiet voids cradled in between. Think about that for a moment. The largest structure in the universe, the way all the matter in the cosmos is arranged, looks like a web. A gentle, glowing, intricate web, spun across billions of light years, forms slowly over billions of years, by gravity gently pulling matter along the threads. We live in one tiny galaxy, on one tiny strand of an unimaginably vast cosmic web. And that web is held together, partly, by the dark matter we talked about, that invisible substance providing the scaffolding, the hidden threads along which the visible galaxies gather and shine. The dark matter laid down the pattern, quietly, and the galaxies followed, lighting up the web like dew gathering on a spider's silk in the morning. There's something so beautiful and so calming about that image to me. The universe, on its grandest scale, isn't chaos. It isn't random scattering. It's a delicate, intricate, web-like structure, formed gently over eons by the patient pull of gravity. There's an order to it, a vast, quiet architecture, woven slowly across the dark, and we're a tiny, shining part of it, sitting on our little strand, looking out along the glowing threads toward the great, quiet voids. The cosmos has a shape, a gentle shape, and we're held within it, woven into the web like everything else. Now let me come back to something close again, and gentle, and warm, because I want to talk about our own sun for a little while. This star that we so easily take for granted. The sun rises every day and we hardly think about it, but it's a star, a real star, the same kind of object as all those distant points of light in the night sky, just close enough that it fills our day with light and warmth. And it is, by any measure, an extraordinarily steady, patient, gentle companion. The sun has been shining for about 4.5 billion years, and in all that time, it has been remarkably stable, quietly, steadily, fusing hydrogen into helium in its core, pouring out light and warmth, day after day, age after age, with hardly a flicker. It's about halfway through its life now, with roughly another 5 billion years of steady shining ahead of it before it begins to change. So the sun is in the calm, stable, golden middle of its long life, a mature, reliable star, in no hurry to do anything dramatic, just gently glowing, exactly as it has for billions of years and will for billions more. And here's a fact about the sun that I find quietly astonishing. The light that's warming you, or that warmed you during the day. The energy in a single sunbeam took an incredibly long time to reach the surface of the sun before it ever started its 8-minute trip to Earth. Energy is created in the sun's core, deep in the center, by nuclear fusion, and that energy, in the form of light, has to work its way out from the core to the surface. But the inside of the sun is so incredibly dense that the light can't travel straight out. It bounces around, getting absorbed and re-emitted again and again, billions upon billions of times, taking a long, winding, random path through the dense interior. And scientists estimate that it can take tens of thousands of years, possibly more than 100,000 years, for the energy made in the sun's core to finally reach the surface and escape as sunlight. Think about that. The sunlight that touches the earth, that grew the plants, that warms the day, may carry energy that was made deep in the sun's heart tens of thousands of years ago, back when our ancestors were still living in the Ice Age. It spent all that time slowly, patiently working its way out from the center, bouncing through the dense plasma, before it finally broke free of the surface and crossed the gulf to us in just 8 minutes. The sun is a slow, patient furnace, holding its light for ages before letting it go. The warmth of the day is, in a sense, ancient warmth, finally set free. And the sun is generous beyond imagining, in a way that's easy to forget. Every single second, the sun converts about 4 million tons of its own mass into pure energy. 4 million tons every second, turned into light and warmth and radiance, pouring out in every direction. And it's been doing that for 4.5 billion years. And it has so much mass that it can keep doing it for billions more. The sun is constantly giving itself away, second by second, turning its own substance into the light that makes life possible. There's something almost tender in that, a star quietly spending itself, age after age, to keep a small blue world warm enough for someone to lie back and feel the gentle truth of it. And here's the gentlest thought of all about the sun. Of all that enormous outpouring of energy, that staggering flood of light streaming out in every direction into the vast dark, only a tiny, tiny fraction ever reaches the Earth. The Earth is just a small dot, very far away, catching only the faintest sliver of all that light the sun pours out. The overwhelming majority of the sun's light streams off into empty space in every direction, lighting up the void, falling on no one. And yet that tiny sliver that does reach us is enough, more than enough, to power nearly all life on Earth. Every plant, every animal, every forest and ocean and field, almost all of it runs, ultimately, on that small fraction of sunlight that happens to fall on our little world. The sun gives so much, so freely, and we need only the smallest part of it to thrive. There's a quiet abundance in that. The universe pours out far more light and warmth than is ever needed, and we get to live in the gentle overflow. Now, let me drift us back out into the deep again, because I want to share one of the strangest and most peaceful ideas about time and scale in the whole cosmos. We've talked a lot about how old the light is, how slow the motions are, how long the sun has shone. But I want you to really feel the deep time of the universe for a moment, because it's one of the most calming things there is, once you let go and sink into it. The universe is about 13.8 billion years old, and a human life, even a long one, is less than 100 years. The numbers are so far apart that they almost can't be compared. So let me try a gentle way to feel it. Imagine the entire history of the universe, all 13.8 billion years, compressed into a single year. The Big Bang happens at the very first moment of January 1st. On that scale, our sun and the earth don't even form until late summer, around the start of September. The earliest simple life appears not long after, but complex life, animals, dinosaurs, all of that crowds into just the last few weeks of December. December, and all of human history, every civilization, every empire, every person who ever lived, every story ever told, all of it fits into the last few seconds before midnight on December 31st. The whole of human existence on the cosmic calendar is the final blink before the new year. We are unbelievably new. The universe is unbelievably old. We arrived just a heartbeat ago in cosmic terms. Now you might think that would make a person feel small and fleeting and sad, but I find it strangely freeing and even comforting. Because it means the universe was getting along just fine, drifting along peacefully for billions and billions of years before any of us arrived, and it will keep drifting along peacefully for billions and billions of years after. The cosmos is patient beyond all imagining. It is in no rush whatsoever, and against that vast, slow, gentle backdrop, all the small worries of a single day, all the things that feel so urgent and so heavy, they soften, they shrink to their proper size. The universe has been calm and patient for 13 billion years. You're allowed to be calm and patient tonight too. You're allowed to just rest in the deep time, a small, new, precious thing in an old and gentle cosmos. And here's something tender that comes from being so new. Because we arrived so recently, in the calm middle of the universe's long life, we get to see it at its richest. The early universe was a violent, formless place, too hot, too chaotic, too young for life. And the far, far future universe will be cold and dim and spread thin. The stars long burned out, the galaxies drifted apart. But right now, in this middle era, the universe is full of light, full of stars, full of warmth and structure and possibility. We arrived in the golden afternoon of the cosmos, when there's the most to see and the most to marvel at. We are not too early, and we are not too late. We are here, now, in the gentle prime of the universe's long, slow day, and we get to look up and understand a little and feel at peace. That's a rare and beautiful kind of luck. Let me give you one more gentle fact about the deep structure of things before we drift further, and it's about how empty matter itself really is. We talked about how space between the stars is mostly empty, but here's the strange part. Even solid matter, the stuff you're lying on, the stuff your own body is made of, is almost entirely empty space. Atoms are mostly nothing. If you took an atom and blew it up to the size of a stadium, the nucleus at its center, where almost all the mass is, would be about the size of a marble sitting on the 50-yard line, with the electrons whirling somewhere out near the stands. The rest is empty, just empty space, held together by invisible forces, which means that you and the bed beneath you and the whole solid world around you is, deep down, almost entirely empty space, held in shape by the gentle interplay of forces too small to see. You feel solid, the world feels solid, but at the deepest level, you are mostly emptiness, woven through with a little bit of matter and a lot of patient force. You are, in a way, more like the space between the stars than you might have guessed, mostly gentle, quiet emptiness, given the appearance of solidity by the careful arrangement of a very small amount of stuff. The same emptiness that makes the cosmos vast is right here, inside you, inside everything. The universe is mostly empty, mostly quiet, mostly space, and so are you. You're made in its image, all the way down. There's a deep kind of belonging in that, I think. You are not a stranger to the cosmos, a small, solid thing in a vast, empty void. You are made of the same emptiness and the same scattered matter, and the same patient forces as everything else out there. The stars, the galaxies, the rogue planets, the rings of Saturn, the cosmic web, and you. All of it the same handful of ingredients, the same emptiness, the same ancient atoms, arranged in different gentle patterns. You fit, you belong. You are not separate from the great quiet drift of the universe. You are one more lovely pattern in it, briefly aware, briefly here, resting under the same old sky that made everything. And so, as we drift on through these soft truths, that's the feeling I want you to keep sinking into. Not the smallness is something frightening, but the belonging is something calming. Everything we've talked about tonight, the sunless worlds, the ancient light, the merging galaxies, the methane seas, the quiet black holes, the thin shining rings, the great cosmic web, the patient sun, the deep time, all of it is your family, in a way. The cosmos you came from, and the cosmos you're a part of, and the cosmos that will gently carry on long after. All of it connected, all of it slow, all of it quiet, all of it yours to rest inside of, just for tonight. There's still more drifting to do, more gentle strangeness waiting in the dark. So stay soft, stay still, and let's keep easing our way through the quietest, kindest corners of the universe together. Now, let me drift us towards some of the very gentlest worlds left to visit, and I want to start with one that's wrapped in eternal storms, that somehow still feel calm from far enough away. Picture Jupiter, the largest planet in our solar system, this enormous striped ball of gas, big enough to swallow more than 1,000 Earths. And on Jupiter, there's a storm, a single storm called the Great Red Spot that has been raging for centuries. We've been watching it for at least 300 or 400 years, and it was probably spinning long before we ever pointed a telescope at it. A storm bigger than the entire Earth, swirling slowly in the clouds of Jupiter, going round and round, patiently, for longer than any storm could ever last on our world. And here's the thing that makes it feel calm rather than violent. From up close, it would be ferocious, sure, but from far away, from where we sit, it's just a slow, soft swirl of color in Jupiter's clouds, turning gently, century after century. It doesn't blow itself out in an afternoon like a storm on Earth. It just keeps turning, slow and steady, a patient eddy in a vast sea of gas, older than every storm you've ever lived through, older than every storm your great-great-grandparents ever saw. There's something almost meditative about a storm that lasts for centuries, turning so slowly and so steadily that, on the scale of a human life, it might as well be still. Jupiter holds its great storm the way the universe holds everything, patiently, for ages, without hurry. And Jupiter does something else for us, quietly, that I think is one of the most gentle and protective facts in the solar system. Jupiter is so enormous, and its gravity is so strong, that it acts like a kind of guardian for the inner solar system. As comets and asteroids come wandering in from the far reaches, Jupiter's gravity often catches them, pulls them aside, flings them away, or absorbs them into itself before they can reach the inner planets. Astronomers sometimes call Jupiter the cosmic vacuum cleaner, or the Great Protector. For billions of years, that giant planet has been quietly standing guard out there, sweeping up dangers, taking hits that might otherwise have come for Earth. We've had a silent guardian this whole time, a great gentle giant in the outer solar system, helping to keep our little world safe enough for life to take hold and flourish. There's something comforting in that the solar system is arranged, almost as if by design, with a quiet protector watching over the calm inner worlds. Now, speaking of quiet protection, let me tell you about the gentlest shield of all, the one wrapped around the Earth right now, the one you can't see but that's saving your life every single moment. The Earth has a magnetic field. Deep in the planet's core, molten iron is slowly churning. and that motion generates a vast, invisible magnetic field that reaches far out into space all around us, wrapping the whole Earth in a soft, protective cocoon. And that magnetic field does something beautiful and essential. It deflects the solar wind, a constant stream of charged particles flowing out from the sun, gently steering it around the planet so it doesn't strip away our atmosphere and doesn't bathe the surface in harmful radiation. The Earth is wrapped in an invisible shield generated by its own slowly turning iron heart, holding the harshness of space gently at bay. And here's the lovely part. When those streams of solar particles get steered by the magnetic field toward the poles, and they collide with the gases high in our atmosphere, they make the gases glow. And that glow is the aurora, the northern and southern lights, those soft, shimmering curtains of green and pink and violet light rippling slowly across the polar skies. So the aurora isn't just pretty, it's the visible sign of the Earth's shield doing its quiet work. It's what it looks like when our planet gently turns away the harshness of space. Every shimmer of the northern lights is the Earth protecting you, made visible, painted across the night in slow drifting color. The most beautiful light show on our world is really just the gentle proof that we're being kept safe. Think about that the next time you see a picture of the aurora, those slow waves of light folding and unfolding across the dark. That's our planet's invisible heart, churning its molten iron, throwing up a shield around all of us, and the light is just the soft, glowing edge of that protection. We live inside a cocoon we can't even see, spun by the Earth itself, and only at the edges, at the poles, does it flicker into visible, gentle, drifting color. We are held, we are sheltered. The Earth has been quietly looking after us all along. Now, let me drift us out to the very edge of our own solar system, to the most distant, quietest frontier, because there's a gentle, lonely place out there that I find strangely beautiful. Far, far beyond the orbit of the most distant planets, there's thought to be a vast, spherical cloud of icy objects surrounding our entire solar system, called the Oort cloud. It's not a tight ring like Saturn's. It's an enormous, soft, sparse shell of icy bodies, drifting in the deep cold at the very outer reaches of the sun's influence, so far out that the sun, from there, would look like just another bright star, barely different from all the others. Out in the Oort cloud, the sun's light and warmth have faded almost to nothing. The objects out there drift in near-perfect darkness and near-perfect cold, taking thousands, even millions of years to make a single slow loop around the distant sun. It's the quietest, most remote part of our solar system, a gentle haze of frozen worlds at the very edge of home, marking the soft boundary between our sun's realm and the deep interstellar dark beyond. And every now and then, very rarely, one of those distant icy bodies gets gently nudged and begins a long, slow fall inward toward the sun, taking thousands of years to make the journey. And when it finally arrives, warmed by the growing sunlight, it grows a glowing tail and becomes a comet, briefly blazing across our skies before swinging back out into the dark. So the comets that have amazed humanity throughout history are really visitors from that distant, quiet shell at the edge of everything, slow travelers from the gentle frontier, coming in from the cold to say hello, just once, before drifting back out for another few thousand years. There's something so peaceful about that frontier to me. The very edge of our solar system isn't a hard wall or a violent boundary. It's a soft, sparse, quiet cloud of icy worlds, drifting slowly in the deep cold, marking the gentle fading of the sun's reach into the wider dark. Home doesn't end with a slam. It just slowly, softly fades out into the night, a haze of quiet ice, marking the place where our sun's gentle warmth finally gives way to the great calm between the stars. Now let me bring you back inward, all the way back to Earth, to a fact about our own world that I think is one of the most quietly wondrous of all. You know that the Earth is mostly covered in water, oceans, deep and vast, covering most of the surface. But here's something gentle to think about. That water, the water in the oceans, the water you drink, the water in your own body, is older than the sun, older than the Earth itself. A great deal of the water in our oceans is thought to have come from the same ancient cloud of gas and dust that formed the solar system, with much of it predating the sun, formed in the cold dark of interstellar space long before our star ever ignited. Which means the water you drank today, the water moving through your body right now, contains molecules that drifted through the cold dark of space before there was a sun, before there was an Earth, before there was anything here at all. That water has been on an unimaginable journey, formed in an interstellar cloud, swept up into the forming solar system, delivered to the young Earth, and cycled through oceans and clouds and rivers and living things for billions of years. And now, for a little while, it's part of you. You are, in part, made of water older than the sun. The most ordinary thing in the world, a glass of water, is one of the most ancient things you'll ever hold. There's a deep, quiet wonder in that, in knowing that the gentlest, most familiar substance in your life carries a history older than the star that lights your days. And here's a related gentle thought. The water on Earth has been here, cycling around, for billions of years. It evaporates from the oceans, rises into clouds, falls as rain, flows through rivers, sinks into the ground, gets drawn up by plants, drunk by animals, returned to the sea, and around again, endlessly, for the entire history of life. Which means the water in your body has almost certainly been part of countless other living things before you, and rained down in countless storms, and flowed through ancient rivers, and floated in clouds over lands that no longer exist. The same water, cycling gently around and around for billions of years, passing through everything, belonging to everything, briefly held by you, and someday gently passed along again. You're not the owner of that water. You're just one more quiet stop on its endless, gentle journey through the world. Now, as we begin to drift toward the end of our slow journey tonight, let me gather some of these gentle truths together, because there's a thread running through all of them, and I want you to feel it. Everything we've talked about tonight, the rogue planets drifting alone in the dark, the ancient light still arriving from the dawn of time, the diamond worlds and the lost twin of the sun, the neutron stars and the bending light, the dark matter flowing through you, the merging galaxies and the methane seas, the quiet black holes and the humming void, the cosmic web and the patient sun, the rings of ice and the water older than the stars. All of it shares something. All of it is slow. All of it is quiet. All of it is patient beyond all human understanding. And all of it, every single piece, is connected to you because you are made of it. The atoms in your body were forged in stars that died long ago. The water in you is older than the sun. The dark matter that holds the galaxies together is flowing through you, silently, this very second. The same emptiness that makes space vast is inside your every atom. You are carried around the galaxy at 500,000 miles an hour while you lie perfectly still. The oldest light in the universe is landing on you tonight. You are not a small thing looking up at a big universe from the outside. You are the universe, gathered together into a small, warm, quiet place, briefly able to look back at itself and feel wonder and feel peace. And I think that's the most relaxing truth of all. Not that you're small, though you are, wonderfully, peacefully small, but that you belong. You are not separate from the great quiet drift of the cosmos. You're part of it. You came from it. You're made of it, and you'll return to it. Your atoms scattered gently back into the slow cycle to become part of new worlds and new stars and new living things, billions of years from now, long after tonight is forgotten. There's no ending out there, not really, just transformation, just the slow, gentle, patient cycling of everything into everything else, on and on, for as long as there is time. And you're a part of that, forever, in a way. Your atoms have always been here, in one form or another, and they always will be. You're woven into the cosmos, all the way through, and nothing can ever take that away. So as you lie there now, in the gentle dark, I want you to let all of it hold you. Let the vastness be a comfort instead of a worry. The universe has been drifting along, calm and slow and patient for 13 billion years. It built the stars without hurry. It scattered the diamond worlds without hurry. It forged the iron in your blood and the water in your veins without hurry. It is in no rush, and it never has been. And tonight, neither do you have to be. There is nothing you need to chase right now. There is nowhere you need to be. The cosmos is carrying you, gently, the way it carries the rogue planets through the dark and the galaxies through their slow merging dance. You can just let it. You can just rest. Think of the old light, still arriving, after 13 billion years of patient travel, finally coming to rest. Think of the comet, drifting in from the edge of the solar system, taking thousands of years to make its slow journey home. Think of the moon, easing away by inches, in a goodbye so slow it spans the ages. Think of the great storm on Jupiter, turning and turning for centuries, patient and unhurried. The whole universe is a lesson in patience, in slowness, in the deep calm of things that have all the time there is. And you are part of it. You move at its pace tonight. You drift at its pace. You rest at its pace. There's a softness to space that we don't often think about because we're taught to fear it, the cold, the emptiness, the violence of exploding stars. But look again at everything we've drifted through. The violence becomes calm when you give it enough time and distance. The exploding star leaves behind a smooth, silent sphere or a beautiful, glowing cloud. The colliding galaxies pass gently through each other without a single star touching. The most extreme black hole sits quietly at the center of the galaxy, the still point everything peacefully revolves around. Even the emptiness, the great dark voids, become a kind of monastery, a deep and gentle quiet. The universe, seen with enough patience and enough distance, is not a place of terror. It's a place of profound, slow, drifting peace. And that peace was here long before us, and it will be here long after. And right now, tonight, you get to share in it. So let your breathing slow. Let your body grow heavy and still. Let the worries of the day shrink down to their proper size against the vast, gentle backdrop of deep time, where a human lifetime is the final blink before midnight, and even the most urgent things soften into nothing. You are a small, new, precious thing, resting in an old and patient cosmos that has been quietly, gently drifting for 13 billion years, and will drift on, calm and slow, for billions more. And for this one quiet night, you get to drift along with it, carried gently through the dark, made of starlight and ancient water, woven into the great slow turning of everything. The rogue planets are still out there, drifting through their endless night, perfectly at peace. The old light is still arriving, soft and faint, from the dawn of the universe. The dark matter is still flowing through you, silent and faithful, holding everything together. The galaxies are still turning, slow and patient, across the great cosmic web. and you are here, a small, warm part of it all, resting in the gentle dark, exactly where you belong. Let the universe carry you now. There's nothing to do and nowhere to go, and all the time in the world. Just drift, just breathe. Just rest, here, in the quietest, kindest corner of the cosmos, the one inside you, where the stardust finally lies still and lets itself be carried home. Sleep gently. The universe will keep drifting, slow and patient and calm, all through the night, holding you softly the whole way, and it will still be here, just as gentle when you wake.